it's Mrs. Compton, and today we're starting off with a number talk. I love number talks because this requires everybody to think in strategy, right? So everybody's strategy may be a little bit different, and we're looking really for what strategy works best for ourselves, right? So there isn't really a most efficient or less efficient. It's just really what's efficient for you. So in a number talk, I just want to remind you, if your classmate says something and you don't think it's very efficient, you actually wouldn't tell them that because maybe that's their most efficient way. But maybe you would raise your hand and say, well, my strategy builds off this one, or my strategy looks like this, and you just share your thinking, right? All right, so our number talk today is 3 times 2/5. And what I want you to do is you can go like this and you can say, all right, this is I'm thinking. I have 1 way, I have 2 ways, I have 3 ways, and so on. So you just kind of keep on thinking. And what you're looking to do is make your strategy more efficient, not less efficient, as you can continue to think. All right, so this is a good time to hit pause. I'm going to hit pause too, and we'll be back in just a second. Okay, I hit pause. I have some guesses as to what you guys are going to do, but first, I want to write down a list of possible answers. So I'm going to just write down some guesses that I think you might have as a possible answer. And teachers, I would love for you to write down the list that is actually occurring in your class. So you guys can hit pause and make your list. I think we might have 6/5 appear on the list. I think we might have 6/15 appear on this list. And I think we might have 1 1/5 appear on this list. And I think those are my guesses for today. So now I want to remind you, if somebody gets it wrong and you're like, oh, I know for sure that's wrong, you just prove it. You would say, I would like to push so-and-so's thinking by, and then you prove that it could not be that one. All right, here we go. 3 times 2/5. I'm going to guess that some of you probably read this to yourself as 3 groups of 2/5. So maybe you did 2/5 plus 2/5 plus 2/5. And maybe you did 2, 4, 6. And then maybe you did 5 plus 5 plus 5, 5, 10, 15. So that would be where that answer would come in. But remember, when we are adding fractions, we don't actually add the denominators together, just the numerators. So this would be an error, right? So we would have to take this off, and that means this one comes out. The denominator is still 5ths. Now, maybe some of you could prove that, right? You could say, I could prove it using a number line. So let's check it out. What would it look like with a number line? So we could start with 0/5. Woo. Then we have 1/5, 2/5, 3/5, 4/5, 5/5. 6/5. Okay, so you could say, all right, if we have to jump 3 times using 2/5, that means this would be the first jump of 2/5. This would be the second jump, so this is worth 1/5, and this is worth 1/5. So this would be the second jump of 2/5. And this would be another 1/5 plus another 1/5. So together that makes 2/5. So this is another jump of 2/5. And then we landed on 6/5, right? So we didn't actually change the denominator. We kept it 5ths, right? So 3 groups of 2/5 makes 6/5. Now, some of you might be saying, I could prove that 6/5 is the answer, but also 1 1/5 could be the answer. Because you can see this is worth 1 whole right here, 5/5. So that means this one must be worth 1 whole and 1, oops, not 6, 5th. Right? So this is an answer, but also that is an answer as well. Okay, I have another guess as to a way that you may have solved this, and then I think we'll move on. I'm going to guess that some of you split the 2/5 into a 1/5 and a 1/5. Did anybody do that out there? Because if you know that 2/5 is composed of a 1/5 and a 1/5, that could really help you. So you could do 3 times 1/5 equals 3/5. And then a lot of you would probably just say, I would do it again because you have another 1/5. So 3 times 1/5 again is 3/5. Put those together, and you have 6/5, which is equal to 1 1/6. So many ways to think about it. Okay, I want to show you a story problem today, and I want to really think about models as we're looking at this. So here's our story. It's about baked ziti. Have you guys ever eaten baked ziti? It's a pasta dish. Hopefully you've enjoyed some ziti before. It's delicious. All right, so we've got Jen is making 4 pans of baked ziti. For each pan, she needs 2/3 cup of cheese. Okay, so just stop for a moment and consider the things that we know for sure. We know for sure she has 4 pans, right? And each pan is going to need 2/3 cup of cheese. Okay, so we know those things so far. It's important to picture that in your head. Her measuring cup can scoop 1/3 cup of cheese. How many scoops of cheese does she need for 4 pans? All right, so let's model this out because mathematicians use models to help them understand, right? So let's get this going. I'm gonna do 4 pans. See if I can fit them all in here. All right, there's 1 pan. You guys draw these pans as well, please. Let's see if I can fit the last one in there. I think I can. Not perfect, but it works. Okay, there are my 4 pans of baked ziti. Now, I broke them into thirds because it says she needs 2/3 cup of cheese, right? So if this is a third, and this is a third, and this is a third, that makes up the whole pan, right? So 1/3 plus 1/3 plus 1/3 is a whole. So, but we know she has a 1/3 cup scoop, and she needs 2/3 cup of cheese for each pan. Okay, so that means she's gonna need 1/3 here and 1/3 here, because 1/3 plus 1/3 makes the 2/3. So she needs 2/3 cup of cheese for each pan. Okay, so that's 1 pan. And we know she has 4 pans. That's this, 1, 2, 3, 4. So for each pan, we know we're gonna shade in 1/3 and then another 1/3, making 2/3. You can do that too. All right, and then the question is asking us, how many scoops of cheese does she need for 4 pans? All right, so each of these represents a scoop, right? So 1 scoop, 2 scoops, 3 scoops, 4 scoops, 5 scoops, 6 scoops, 7 scoops, 8 scoops. So she needs 8/3 cup of cheese, but that's not the question. So 8/3 cups of cheese. But then we have to go back and consider what the question actually is. How many scoops of cheese does she need for 4 pans? Well, the answer to that was 8 scoops. So if we write 8/3 as our answer, it's actually wrong because she doesn't need 8/3 scoops of cheese. She needs 8 scoops. And that's why we model with mathematics, because you can actually see it. I can count out 2, 4, 6, 8, right? And I'm sure that you probably have lots of different ways of thinking about this, and that's totally fine. That's what mathematicians do. We build off the ideas of others, but it's also nice to see the visual representation, right? That's important too. All right, kids, grab your stuff. It's your turn. I'll see you next time. Bye.